All right, today we're going to look at the roller coaster. I know you'd rather be out fly fishing on the Miramichi River, the old Norwest, but instead we're here. We're doing math right now. It's a Tuesday afternoon here in Pontiac High. Remember to like and subscribe. All right, so the roller coaster, as I stated, you'll see what I've highlighted. I know off the bat that the highlighted section is really important. And why is it important? So, Kathleen and these guys here, all this is saying is that piece right here exists between 0 and 5. So this right here is 5 and 10. Because this is saying y is equal to 10. So it's a constant function. And then we're always looking for what is the handoff. So there's my handoff. Okay. And then now, if I look at that there, I've got a simple point and I've got a vertex. How do I know that this is my vertex of the next function? It's at the top, but what's weird with square root functions is it didn't necessarily state that that was the vertex where it handed off, but what it did tell me, right there, they're saying it without saying it. That 5 right there is suggesting that, well, my h and k exist where x is 5. So that means that this has to be the h and k. So again, another one of those diagnosing things. They often do that with square root functions. They like try and hide it that way. So they're just seeing if you're paying attention. Because otherwise you'd be frozen. Like that's what I find very frustrating about this question is if you didn't see that right off the bat, piecewise functions are brutal, and that you'd be like, I don't know where to go from here. I'm frozen because I don't have enough information because you couldn't find the h and the k. But now that I know that, and I know that I've got the 0.9 and 6, my first step would be find a1 by plugging everything into the square root function. So I have a y of 6, an a that's unknown, an x of 9, h of 5, and a k of 10. So we're just going to rearrange and solve. A square root 4. So negative 4 is equal to a times 2 divided by 2 divided by 2. A is equal to negative 2. So now I have my a and my k for the square root function. So I'm ready to move on. So what do I do now? I look at what's the next handoff point. 21. So step 2, find y when x is equal to 21. And that's going to be the next handoff point. So now I'm just going to plug that in to negative 2, 21 minus 5 plus 10. So it's always like find a rule and then immediately use that rule. So then y is equal to negative 2 times square root of 16. Y is equal to negative 2 times 4. Y is equal to negative 8 plus 10. Y is equal to 2. So, yeah?
Could you just super quickly explain how that chart works?
How the what?
That chart works.
The chart here on the right. So all it.
I think I understand how it works, but
here's what I'm going to do then. I like that question.
We're busting our brains over something
Okay.
here.
I wish I could pause this thing because I would love. It's the only problem. But my other device that records my stuff, like it creates files that are way too huge. But here, I won't take much longer on this guy here. So Jackson, really quick, 0 and 5. What it's saying is that piece exists, and we don't care about anything else. Remember we were talking about domain? Domain strictly deals with the x-axis. So all it's saying is this piece only exists where x is in between where x is 0 and 5. It then goes on to say, and I'll use a different color, right? This piece here exists between 5 and 21. Right? So then I know that this handoff point is x is 21, and then I just found out that when x is 21, the y is 2. So now I have that point because I know that that's where it handed off.
It's just writing the
Mhm.
graph, but in math.
Where does it exist? So that's why the handoff, that's why I call it handoff. It's piecewise function, but and they're not all like this, but a lot of them you're looking for what's the handoff point. And how do I determine the handoff point? That little chart there. So that the next one exists between 21 and 30.
The graph, but in like numbers.
It's giving you the type of function that you have. Okay. It's giving you what type of function it is. And so Jackson, you can also sync it up by looking at the diagram as well. The only ones that are tough, if you can see here, see the green one and then now see this pink one. Okay. The pink one and the green one are the ones where you like need to know what it is because of the way it's shaped. A rat, you could just be looking at one piece of it. But I mean, I could also look at this and maybe say that that was the square root. But I know that it's a rat because it tells me down here in that chart. Otherwise, I wouldn't know how to approach it. It would have to tell me somewhere. Exactly. So without seeing it, right, you have to go through it. And what was your question?
Well, how do we find the k for the rational? For the rat? Because we found the starting point for it, but we can't find the k. I don't know how to go about that.
So when you, let me just skip down through the absolute value function one, because you have the 36 and 10,
Yeah.
and you know that the h is 27.
Yeah.
And what's weird about it right now is that that x value is 30. So this guy here is, he's starting there.
Yes.
It's frustrating because like, so the 27 is like right there.
Yeah.
So it's like 3 units away from it. So it's not like you can just take the 30 and then figure it out. But what you can do on that guy there, we have the absolute value function. It hands it off where this is 30.
Yeah.
So then
We found our y there. So
we've
is
got
this 30,
that.
is 30 and 6 the vertex? Because the vertex has to be the
Not necessarily like the 30 and 6 is just going to be an x and a y.
27, we don't know.
Oh, did you plug this in and get that point?
No. Yeah, we have the point for.
But the problem is you have an a and a k.
Yeah.
Is that what you're saying? You're looking for both. Okay. So if you have an a and a k and you have a point, this is where we're going to have to do the comparison method stuff again. Because if I ever have two variables, and this is, I like the construction of this question because we're down at the end. If we got down here and got stuck, I totally get it. But whenever you're missing two, you've got to split it up and set equal to k. And then solve for a first and then plug it back in. Because you're going to have the 30 and 6 that you got from here and the 36 and the 10. You'll set them. We did one like that, but I think we did it with an absolute value one. Yeah, let's do it right now.
Yeah,
I did find those ones and add it to the, Buddy has the, but yeah, I should, comparison. Yeah.
Join together like 5 and 5 for the points at the end. Like the monkey one. They hand off each other.
The 5 and the 5? What do you mean?
Like, oh, you mean for the first, like the square root function? Like the 5, put them together.
This one, that one?
We only go from 5 to 21, so then we know.
So we just know the beginning and end now.
Yeah.
So that's the only thing that's helpful to us now is that we got the beginning and the end. So you'll see on this step here, I plugged in an x is 21 because I'd found the rule for the square root function, right? So I plugged in x is 21 just so I could figure out what was the y when x was 21. And then I'm into the next guy. Yeah?
It gives you, doesn't it give you like an H or a K for the
It gives me an H and K for the for this guy right here, yeah. Yeah, you totally could. I like that idea. Oh, I really like that idea. 26 and 20. So this is 26 and 22. So if I want to find the A value of this guy, I could just use 21 and 2 and 26 and 22, and that'd be way easier. So I'll do that actually. I like that idea. Wouldn't matter which way you did it though, but like A is equal to y2 minus y1, x2 minus x1. Jody, are you getting through this one on your own? Then focus or work, not chat. So then I would do the 22 minus 2, and then 26 minus, what was the x of it?
21.
So that's going to be in the new YouTube video.
Yeah, all right.
Makes that epic intro.
20 over 5. A is equal to 4. Only problem is absolute value function is facing down. So what is my A value going to be? It's going to be A is negative 4, not just A is 4. So I change that negative. So then finally, did you guys, that's my A value.
So
So
then can't you just use 45 to try and find the...
So then we're still in the absolute value function now, negative 4x minus 26. So that's the one mistake people will do is they'll find the rule and then they'll forget to use that rule. They'll skip down to the next rule automatically. But it's like, I've got to find the absolute value function rule so that I can then plug in the x of 30 to find the y so I have the handoff point. That's what I'll call it.
Oh, I know what to do.
So then y is equal to negative 4 times 4 plus 22. I didn't need to do that step by changing the brackets, but I wanted to show you, like, if it was positive, it stays positive. I do want to show that I changed or got rid of the brackets. And then y is equal to 4, 6. So 30 and 6 is a point that I can use. Question?
No, I think I understand. Is it like we're just trying to find the rule for the last line?
Mhm.
Try to say, so whenever x is 40, what is y?
Well, what is the height of the roller coaster at 42 seconds? I think I changed it that way.
Well, 40, what is 40?
Whatever.
So at this point, don't you just like find the rule for the rat there?
So the problem with the rat one, so if some of you got to hear, that is amazing. What are the roadblocks to this one? I would say I've had this one on a test, and the fact that the h was 5 and it says it there, and the fact that this constant function tells me that that's 5 and 10, knowing that that's the h and k of the square root function was like a huge block for people to get through down to this section, where now I can use 30 and 6 and 36 and 10, right? Those are 2 points that I have. And if I look at the rule as it stands right now, x minus 27 plus, what did we say? Okay, we don't know k. So now, they were saying it, right? If I just plug in, let's just say 6a 30k, I'm missing 2 variables. Whenever you're missing 2 variables, this is when, and we were talking about the systems of equation stuff, all that stuff from last year, whether it's comparison, whether it's elimination is actually sometimes useful this year, specifically with logs. So we will kind of go into it. They just look a little different now because each one of these functions is unique in its own way. So I'm not just going to write that function down. I'm also going to write down 10 is equal to a over 36 minus 27 plus k. So I'm just going to simplify this guy and isolate for k. So 6 is equal to a over 3 plus k. 10 is equal to a over 3 plus k. And then I'm going to bring the whole thing over to the other side. So k will be equal to 6 minus 8a over 3. Sorry, my a's look like 9s. and then K is equal to Pobity's Nerfect, right? Pobity's Nerfect.
Fake Latin.
Sorry. I'll see myself out.
Sir, there's the door.
So then I'll write down here that this is my comparison. So again, huge skill set here to develop. No, I mean, that's why I wanted to show you the skill set. That's why these guys are really tough, is it's sometimes. This is probably the hardest type of these questions I've seen because of them adding this at the end.
Because like I was looking at this and like you don't need to do anything except for the last part.
Mm-hmm.
Because it just.
But it's getting to the end.
Dude, that's the thing though, like because it gives you a point.
But you had to find the 30 and 6. You needed 2 points.
But that's the thing though, like if I didn't know to do that.
You didn't know, you would look at it and say, I have a point and I have the HK. What's going on here?
Yeah, why would I need to do all this work?
Yeah. But you're missing enough. So then now I can rearrange this guy. Right? So bring it whatever way you want. The comparison method here. So 6 minus. So I'm going to have 4. Oh, I changed, sorry, 30. That's my bad. Up here, my bad. 36 minus 27. There's, oh my gosh. Why would they make it A over 9? This is impossible. A over 9.
I think that's a you problem.
It is definitely a me problem. So then now when I combine these guys together, it's just fraction math.
So they look.
Right? Because then on this side, I'm going to have positive A over 3 and minus A over 9. As you can definitely see by the one above that.
Need to make another 9.
This 9 needs to be better. That looks like an A.
Okay, wait, is it A over 3 or 9 over 3?
That looks like an A.
What?
Is that a 9? It's a better 9.
So
No.
What can I do to my A's to differentiate them?
9 over
so when you do an A, instead of doing this and having like your A come out,
the negative.
What? When I brought the A over, I would have added A over 3 to that side. So then now I would.
Bringing the 10 over to that side, which is a negative 4.
Yeah.
Okay.
So then now the only problem is I'm going to have to like modify these values. So 3A over 9 minus A over 9. Where I knew I was going a little too fast here, what I knew I made a mistake was if I brought the A3 over and added it, they would have just disappeared and I wouldn't be able to find an A. So I went back up and was like, right. I assumed that those were the same value because my writing is terrible. But it wasn't. So now I can combine it. Negative 4 is equal to 2A over 9. This, if you can remember dealing with your fractions, right, you can kind of cross multiply it, right? Or I can just multiply both sides by 9. Negative 36 is equal to 2A. Divide by 2, divide by 2. A is equal to negative 18.
will a question like that go on the test?
Yep. With the comparison next Monday. So then last but not least, you would then say, okay, that was just me finding the A. And that's the hardest part. Now I can take, so that was just the comparison method. That was just step 5, finding the A. That was all the biggest part of this. So just as a review, I plugged in these 2 points right here separately, then isolated for them, then used my comparison method to have them set opposite each other, and then just rearranged and did some fraction stuff. So then my next step would be to then find K. So you could then go, okay, I'll take the 30 and 6 and plug that into this function now. Negative 18, 30 minus 27 plus, what was it? Plus K. Plus K. And I'm going to throw this guy here and that guy there. And then now we can solve for k, because it's the only thing missing. So 6 is equal to negative 18 over 3 plus k. 6 is equal to negative 6 plus k. K will be equal to 12. So now the rule of this guy is going to be negative 18, x minus 27 plus 12. And last but not least, this is again, these are complicated and long. I will tell you that these in conics are the biggest questions. And then it just becomes more complex but less work. So number 7, find, does it give me an x or does it give me y? What is the height? So what is the y when x is 42? Find y when x is 42. So y is equal to negative 18, 42 minus 27 plus 12. And then solve. That was a beast.
Sir, what's your outro going to be?
My outro for this one?
Thank you for fly fishing.
Thank you for fly fishing. Thank you for taking the time. Thank you for taking the time to math with us today.
Thank you for mapping it up with me today.
Mathing it up with Sweezy. Remember to like and subscribe. So then last but not least, finish up that ugliness.
Thank you for being my algebra.
That's the ending right there. That's the outro right there. That's perfect. Oh, positive 10.8 is my final answer. That is the height. Thank you for being my algebra today.